Hi dear students, in the last class we discussed about the basic terms of strength of material of the first class, and today's class will discuss the very important curve in the engineering material. In engineering material we will get two types of curve, for the ductile material and for the brittle material. Two curves you will get, one for ductile and another for the brittle material. Ductile material example is mild steel. So let us see the different terms in the stress strain curve for ductile material. When you are testing the mild steel in mechanical testing lab through the universal testing machine, we will obtain different values, how the load is going to be increased. As the load is going to be increased in the universal testing machine, the mild steel specimen starts yielding. It starts from the different limit. So in this curve we will discuss that one by one, so that then I will explain how this is going to be implemented in the engineering material selection. Here they are drawn x-axis and y-axis. Along the x-axis they are shown the strain. This is very important first. Along the y they are shown stress. Along the y they are shown stress. Now here how the curve will start. First of all, it will start from this 0 point. As the load start increasing, the point A is called proportional limit. What is the proportional limit? We will see first what is proportional limit. Proportional limit is the stress value at which proportional limit is the stress value at which the stress strain curve begins to form the straight line. Means here in this the line is straight. The line is straight up to point A. That means what? The stress value at which the stress strain curve begins to form the straight line. The initial loading point, the stress level is less, and the straight curve we will get, stress and strain proportional we will get. That's why we are calling it as proportional limit. Stress is proportional to strain in this limit. Then second point B is elastic limit. So what is elastic limit? It is defined as the stress developed in the material without any permanent set. It is very easy to understand. Let us see in the curve. The point B is known as elastic limit. What is elastic limit? You take example rubber. When you stretch rubber, what will happen? The length of the rubber will increase. It will increase up to its elastic limit, and when you leave that stretching points, so what will happen? It will come back to original position. That means whenever you are applying a load on a body and after removing the load, it will come back to its original position. It is called elastic limit. The same has been explained in the definition. What is here? It is defined as the stress developed in the material without any permanent set. Means it will come back to its original position after the load is being removed. And the next comes upper yield point. Upper yield point is shown in the C. as the load goes on increasing, as the load goes on increasing, so what will happen? This upper yield point will form. What is upper yield point? The stress corresponds to the yielding of the specimen for the tensile load, and it will start deforming permanently. Yield means what? It will start forming the permanent set, means it will not come back to original position. It is beyond the elastic limit at which the material will start yielding. Material will start what? Yielding. It is very important to remember what is yield point, upper yield point. Material will start yielding at that point for the particular tensile load, and it will start deforming permanently. Means even though after removing the load it will not come back to original position. आप लोड रिमूव किया तो भी वो ओरिजिनल पोजीशन को नहीं आएगा, जो उसको क्या बोलते हैं हम? अपर यील्ड पॉइंट बोलेगा. सो नेक्स्ट, as the load is increased, and suddenly what will happen? The material yield point will collapse. So that point is called what? Lower yield point. So here it is shown in the curve. We will see first of all what is lower yield point. The point D is called lower yield point. Here point C is upper yield point, and the point D is called lower yield point. Let's see what is lower yield point. So lower yield point is the stress corresponding to the yielding that a small load drops to point D. As the load goes on increasing, what happens? There is a drop in the load, small load. Then immediately the yielding comes into a permanent deformation. So that is a range of plastic deformation will start. What is plasticity? So as the load goes on increasing, and even though if you remove the load beyond the elastic limit, the material will not regain its original shape and size. Means it will not come back to its original shape and size. वो अपना original point को नहीं आएगा. Means the material is deformed. Okay, the main intention of finding the tensile testing is to what amount of deformation before and after. Before the test, length is measured, and after the test, length is measured, and we can find out with equation what amount of stress, strain, and the deformation has taken place in this specimen. Next comes ultimate stress. What is ultimate stress? In the curve you can see the point E. The point E is known as ultimate stress. So what is ultimate stress? Ultimate stress, it is defined as the largest stress value attained by the mild steel. Means here as the load goes on increasing, the stress level also increases, and because of that mild steel will be under extreme pressure, and that reaches to the ultimate stress. And beyond that, as the load goes on increasing, what will happen? Material will break. The next point is breaking stress. The breaking stress is the value of stress where what happens? The specimen breaks and the stress value is less than the ultimate stress. Means as you goes on increasing, means you take the chalk and just put the you hold in the two hands and for the pressure. So what will happen? The chalk will easily break. But whereas you take some metal piece and you goes on putting the load in both the hands, it will not break easily because it is having the more strength than the chalk. Chalk is a brittle material, so metal is having the very high strength than that, so it will not break easily. But even the metal also, beyond that load resistance capacity, it will withstand, but beyond that metal will also fail. In engineering, whenever you designing any complex machine parts or any critical machine components, it is very essential to check the mechanical properties testing. So then only you can use that material for the particular component. Otherwise, it will lead to big injuries or loss to the companies. So this is what about. Now I was explaining about the final point is breaking stress or failure, where the material will fail. So 1 second we'll recap this curve. It consists of different parameters: proportional limit, where the stress strain curve is straight; elastic limit, where the after removing the load it will come back to original position, and as the load increases, upper yield point will build at point C. As the small load drops, it is called lower yield point, and as the load increases, what happens? It reaches to the ultimate stress, and beyond the ultimate stress, as the load increases and the material cannot able to sustain that load, it is called the breaking stress, where the material will fracture. So I will show here a small example how the testing is done. So this is the component. Here two upper and lower holding point is there in the ultimate universal testing machine. And what happens, as the load, tensile load is applied, tensile means opposite loads are applied, two equivalent opposite loads are applied. So what happens, as this gripper moves up and this gripper moves down, so due to that the pressure, the load is under here at this necking middle region. So what happens, the material starts deforming like this. Material start deforming. So just I shown means this is what final happens, and finally it will fracture. So length of the material is increased because of tensile force, and the calculation is done for checking the mechanical properties. And you want more information on this stress strain curve for the ductile materials, even in the YouTube you have got so many videos for practical demo they have shown it, and even in your lab you have got a lab, mechanical testing lab, in that also you are performing the experiment. This is about what stress strain curve for ductile material. And next I will discuss about stress strain curve for the brittle material. So stress strain, which is a brittle material? The material which contains the carbon in the high amount, means more than 2.5 to 4.7% carbon, the material is called brittle material. So example is cast iron. So here the cast iron, it is very easy to understand. It has got only 2 points. So here you can see, just a minute, it's a problem. It has got only 2 points. One is point A and point B, means it is a proportional limit. At a point A is a proportional limit where the stress strain curve is straight, and as the load increases, and if you remove the load, it will not come back to original position. It will fracture easily and it will break easily as compared to the ductile material. That's why it has got only the 2 points. Here it will not come elastic or the upper yield or lower yield point or ultimate stress will not come here, because cast iron will break easily at lesser or lower load than the ductile material. So that is what breaking stress. So here also it has got x axis and x axis and x, just a minute, it's giving problem.